Guys, so I really want to talk about something really cool. I was talking to one of my coworkers about this the other day, and it's gravitational lensing. The idea of it is just absolutely phenomenal, and it kind of has to be the proof as to why astrology is a pseudoscience, as opposed to astronomy. So the simplest way I guess I can kind of describe it, that I was explaining it to her, is when you look at, say, a constellation in the sky, let's just take Orion as a perfect example, you see pretty much three stars as the belt. And that was usually the easiest way that people can kind of distinguish as to where Orion is in the sky. They see the belt, which is three stars that kind of go up like that. And a constellation is made up of, a formation of a few different stars. Now, the thing is since stars do have a mass and they do have a gravitational pull, what starts to happen is it actually can bend space-time. So space-time is pretty much like this leaf. So we, based on Einstein's theory of general relativity, it runs sort of like this. And what starts to happen is when you take something like, I want to find a stick somewhere. Okay, like this stick. No, like this rock. Perfect. When you take something like this rock, which let's say it's a planet, or we can say it's a star, and you put it on the space-time, it starts to bend because of its mass. So what's happening now is it's bending. So what starts to happen is when something like light, let's just take this piece of grass as looking at as the light that's traveling from one area to another. Let's say that there's a star here and you are here and you're observing this star. It will actually, when the light starts to travel, will start to bend with space-time. So it's traveling like this and it can start to bend due to another body of mass that it passes on the way to where you are, which is where you're observing. So the way that it appears to us is like as if it might be, say, right here, but really when you turn it on the side, it could actually be all the way over here. So what starts to happen is when it's actually going to pass by you, it gets pulled in by the gravity of whatever this nearby object is. It bends through space-time and then it goes over to you. This is what gravitational lensing is all about. So gravitational lensing is the bend of space-time at where light travels from point A to point B, or point A to point C, D, etc. So another really cool thing about constellations is that sometimes when we see a constellation, it looks like as if they are maybe the same size. So let's just take this as an example. There's two stars that we see in the sky. And from where I'm standing to where you are, on the other side of my camera lens, it may look like they're actually the same size. But one of them may actually be back here, but it could be a lot bigger. So let's take this leaf as an example. It's very, very big leaf. You can see up close that it's a lot bigger. But when I pull this one back, to you, it may seem like it's actually the same size. But what's actually happening is it's just more luminous. So for what I'm describing here is more so on its size. But when it comes to stars, it's actually more based on their luminosity, which is just how bright the star is. It's super simple, kind of, unless you want to use the formulas, which we can get into in another video. But that's just another big factor. So what starts to happen is you see it looks like it's actually the same size. When you turn it to a side, it can be light years apart from each other. So that's another reason as to why with constellations and the fact that we track them, and the Greeks, like, decades and decades and centuries ago were studying the stars, and they started to come up with constellations and astrology and people, the way they were born, the star formation was. It's kind of become a pseudoscience just because, the constellations shift a lot, but also the fact that, to us, it's just an optical illusion. It's just what we see from our specific point of view. But the way it actually is out in, outer space, it's actually totally different. If we were maybe observing it from, another planet in our solar system, or say another solar system in another galaxy, it will look totally different. It won't even look like Orion. It wouldn't even be recognizable. So they wouldn't even know what a Scorpio is or what a Leo is or anything like that, because the constellations are going to be totally different. So anyway, that's a really fun topic I like to talk about, is gravitational lensing. So thank you again for watching, and be sure to subscribe below. Okay, peace out. Astro Athens. Bye, guys.